Testing, sound is good. Okay. We shall see how well the stream survives this time. Okay. Sure. So, it's time to work on physics. The implementation of the basics of XPBD physics engine for my game. Just planes, spheres for now. Simple start. For now, I just need to collapse shapes and positions. Right now I can spawn a bunch of them, but I'm not doing anything. Right, start with two shapes, which I have. Ground as plane. Ball as shape of sphere. Dynamic static. Predict solve update velocities. Mass, okay. Roll sphere to plane, sphere, sphere. Okay. Update. What's up, A? Who's cracking? Today it's time to learn from AI. Well, before I jump into constraints, let's just do gravity to get started. Gravity to get started. This is already getting called, right? Yeah. Okay. Yeah, it is. Let's see. Physical Rigid dynamic. This is Visual Studio 2026. Actually, this is to be moved up here so it doesn't take as much space. Dynamics. 2026 is out. That's right, officially. Official. I've been using Insider version for like 2 months already. Now, sadly, you cannot yet compile it for Steam builds. Gotta wait for Steam to release updated distribution package. Query statics. Shape of sphere. Thoughts? Seems better. Seems better. I mean, honestly, I don't see much of a difference aside from slightly reworked UI, which I glossed over pretty quickly. I don't even remember now how 22 looks like, so that stuff is minor. I think the main thing for me maybe was like a newer C++ 23 features. Maybe something worthwhile there. Kinda doubt. Maybe. Ghost errors, what is that? Like Ghost in the Shell with some hot check comes out? Don't know about that. Haven't seen that yet, unfortunately. I need to restart. It's some kind of array. Then I would need to write it all back. Guess since you don't mind. See if the errors makes project unable to build. Don't know what it fixed it is running. Huh. Not sure. I use Git CMake, so I haven't seen that. Not sure. Not sure. Maybe if using some kind of fancy builds. Not sure. But if it's something that kind of rarely happens, that might be a pain. You're gonna have to find a good repro on a small scale to give it to them. Otherwise, it might never be fixed. But that kind of stuff could be hard to track down. Position. For that for now. Yeah, I mean, the thing is, it's MS build underneath either way, so that doesn't change. Like when I build now, it's all for MS build. CMake is purely to generate solution file. After that, CMake does nothing. I'll just do gravity for spheres at first. Supposition. I want to update position in place. I guess for now I could. Indeed. Maybe position component. Boom. Dynamic maybe. Ouch, day 6 delayed. Indeed. So far. All right, so here. PC ported in 2 years so far. We'll see. If I need this. What does the physics engine do in a game? Simulates physics. Right now, the new one, I don't have anything new yet, but anything time you see like objects bump around like that, that's physics. Also, raycast to see where the laser starts, laser begins, what it hits before it does something else as opposed to pierce through. All that is physics. Alright, let's collect them all. Destruction is indeed nice. Currently using Physics 5, but I'm starting a side project. Building my own physics engine. I do need some persistent data. Making an engine from a game. I guess. Where do I store persistent data? I don't have to just copy over. I think I need to do maybe a different approach. Yeah, fine. Yeah. Before I get a pointer to this guy. I need to modify that too. I just need it. Physics. Physics will be missed mostly. Of all the libraries I've had, I think Physics 5 probably gave me the least headaches. In some distant future, we will also recast replays. The pointer or an index? Only been doing game dev for this specific game is getting close to 2 years. Full time. I'm just gonna give it an index. Okay. Should be not that intrusive. Okay. So that will be set once you have something. Am I rich? No. No, I'm not. Ubuntu. Sounds like pain. Indeed. Everything is ready except good tools. Fast, yeah. If there's something to do well at speed, that would be nice. So let's see. First I want the entity. Probably. Near them. Well, good luck with debugging. Let me know how that goes. I mean, for now, it's fine. Mm-hmm. Indeed. I delete Windows. Smart. Smart. Need this. Okay. Do it this way. Yeah, that's not gonna fly anymore. Don't Snowden, huh? I guess. No idea. I think if in the future I'm gonna want something here. Resharper settings. I just use JetBrains default pretty much. Nothing all that special. Nothing all that special. Okay. Bunch of boring setup. that. Might need to be in the future move this out, but you know what? That's fine. Start here. In this case, I mean, Medium sharper, yeah. How's the performance? Well, I have an insane CPU, so I don't notice any problems. But when I'm using like a weak laptop, then yeah, it's gonna be rough. It's always rough in the beginning, but once it indexes your stuff, it's not too bad. Bro. Yeah, get that. Okay. What I do need is sort of this for now. Get position is fine. Set that, set that. Actually, I do need. That's where the index stays the same. Okay. This. Hey, that takes care of reuse. But turn off those predictions. Annoying. Right? That's actually fine. of that. That's positions. Get some. I'll just start that. Okay. Yeah. Okay. Let's see. I don't want to spend too much effort on this, but just the basics. Okay, so to get initial positions, same thing here. Passing that on. This, unfortunately, probably requires a full restart. Yeah. Yeah. Okay. Okay. This out of the way. Let's do the first thing. Simulate velocity movement. Yeah. Gravity. Seems good. Goes velocity. So that's this. Just basic gravity. Okay. Now into interesting things. All right. Don't care about all that. A step. External forces I got. Predictions I got. Self-constraints. Yeah. Oh, it does save positions. Does need positions from before, which makes sense. Which makes sense. Mm-hmm. Mm. Okay. Because it's kind of annoying. Need delta, probably need delta either way. Okay. Now let's walk through a sphere to plane. Yes, sphere to plane. Oh, we also need mass. We'll need a mass. Just fine for now. Okay. Let's focus on the CQ formula. Slowly explain each term. I don't have plane yet as a body. Let's thinking. Position is fine. Normal. Right. This one doesn't even have it as a thing. Type of shape is fine. Oh, I'll just dunk it as this. Well, everybody's brain's limited, no, regardless. Either way. Do this double thing. A bit of a rework. No capacity. Otherwise that. Grab set. Okay. Passes it on. This part is. Wait, this is static. I should fly. Yeah, good. That thing is already the thing. Okay. Now this thing. You. All position being sold this iterations. Predicted position, right. You can use a constraint function. Distance joint. Quality, right. So sphere to plane. Now the delta is a gradient, right? Verse, yes. Multiplier. Compliance softness. Okay. Okay. Thing. Say delta, compute it. Right, that expansion. Upside. Compliance parameter. Let's skip the delta accumulation for now and just do basic constraint between a sphere and a plane. I'll go back to delta after that. So I could do subdeltas here. Maybe. Maybe. Plane using sign distance makes sense. Right. Sphere in a plane. Normal of a plane, x, s.x, what is that? X is a position. X is a position. I'm not sure I'll buy this. I think this should be... Oh, is it offset from the center? Right, okay. DZ offset from center. Okay. What's up, username? Working on some physics engine. Physics engine. Particularly the method of expanded or extended physical position-based dynamics. Yeah. Expanded position-based dynamics, XPBD. Okay. Find the offsets. To math for now. C of Q between sphere and a plane. Your center radius. You do have position, right? So between normal and position, I can deduce that. Fair enough, fair enough, fair enough, fair enough. So, anything that's a sphere. Indeed. Force, mass, time, acceleration. Force comparison for now. We'll even just assume there's only one plane. To follow T-dub. T-dub. Let's see. Right. Cut the plane. Constrained form based on the X, right? What is that? What is the gradients of X by C and of Y by C? X sounds like its position and its radius. Hello world on GCC. Not even using Clang. If I'm a particle I slightly, in which direction does C increase fastest? The particle's position. Fair, fair. Some reference point on the plane. Yeah, it makes sense. The moving sphere, but along the normal makes sense. Oh, increase radius. I don't care about that. Fine. The Q here is meant to be position again, as opposed to the other thing. Then move each particle about delta x. Inverse mass. This thing and see. A question to answer complicated physics questions. Have a shot. See if it's something I know. Key positions being solved, right? Constraint. And the compliance, the softness. I see. 0 perfectly rigid. Well, let's see. Makes a full spaghetti. Why don't we feel a continuous downward push? Well, sounds like somebody needs to take a middle school or high school class. So given its current position, I can call it even a Q. We need to compute gradient constraint of Q. Also need an inverse of mass, which I already have. So it kind of makes sense to call it X in this case. I guess I need a delta. What's it called again? Delta Lagrange. Oh yeah, I guess this would actually be a vector, isn't it? It's a vector in it. Type of video game. A Diablo-like. Run around, destroy stuff, attack robots, get loot. Hey. But right now it's a side project. Working on physics. Working on new physics specifically. The delta inverted to mass. Lagrange gradient. Okay. Let's look at an ingredient. Gradient of constraint. Gradient constraint. Is an gradient of constraint of Q simply a normal along the direction that separates the objects fastest? Using ChatGPT giving hardest like prompts. Yeah, it's talking to me about math problems. Because implementing physics involves a bunch of math. And this I've never done before, so I'm learning that from AI. Yeah, so constraint of Q is a direction of separation, fastest separation. For any constraint, the gradient is a 3-vector points in the direction of when it increases the fastest. Yes, okay, that makes sense. Yeah. I do like that kind of derivation. It'll be curious to compare GCC and Clang. From what I'm seeing, Clang is slower than Microsoft Studio. But maybe it's slower than GCC as well. Because constraint C of X. Constraint function for position of a sphere relative to a plane. It would be C of X. Yeah. What is this formula for? This is for position-based dynamics with some expanded XPBD to it as well. I'm curious. It's a plane of plane NG, meaning it's normal and offset. X, okay. Sphere XR, X is center is the radius. What is DPR? Well, this is PBD. I'm not sure where you're seeing DPR. Oh, XPD. XPBD. XPBD. Otherwise known as, what's it called? Expanded. Oh, I didn't even explain it. But anyway, it's expanded position-based dynamics. It's a more stable version of implementing that. So something like that. I've already gone through this little paper. And there's even YouTube videos about the guy who wrote this. So I got some gist from this here, right? I think the math here as well. Well, he kind of described in slightly different fashion. But anyway. Yeah, well, it's more specifically about control. The physics I already have is already pretty good in the game, so I don't have particular complaints of it right now. I do have some concern when I'm working with like really long hair like this one. Under certain conditions, it does behave a little weirdly, which it gets like punched by something. Then it gets extends a bit too far. But it's more about control in the future. For example, right now, it's kind of hard to add clothing that's simulated on CPU, as this engine doesn't support it. So I'm kind of limited some parts. So constraint function for circle at X. And gradient of C of X is an guess I'll call it this. But hold up. Ooh, thank you. Thank you. I'm forgetting I physically muted the mics too. But sounds good. So, okay. It's kind of cute. So gradient of constraint is the vector alongside which separation increases the fastest. That part is fine. I understand. Delta Lagrange is something else. I've already looked before. What is the Taylor series? Basically expansion of that. Oh, this is talking about derivation, right? Yeah, because we're really looking for this. Yeah, position-based solvers move each body along the constant gradient, constraint gradient, right? Right. This is what I want. Where have I been? Just take a step outside. Took a step outside for a bit. But it's all good. All back. Gradient. Gradient. U of Q. Let's see if, yeah. It's this thing. CQ on its own is a vector distance. The scalar. Because that's a dot. Scalar. On is a distance, I see. Okay. Okay. I understand. Beef, indeed. Beef and hot dogs. But I'll load it up now. You take the current equation. So the larger separation, the bigger the correction. And the sum of nurse weights times the... Interesting, this adds that. So square of time step each way. Technically, would want us here. What is this? This is a delta. Let's go back to... I had this somewhere, deep dive somewhere here. Yeah, this part. So I understand what this part, C of Q, I get. constraint function, right? Yes, yes. The gradient, which is just this, right? Compliance, compliance. Perfectly rigid constraint, interesting. So perfectly rigid constraint. I don't even need that part. So I may not even, well, here I don't need it. So let's focus this part. Effective mass term. Effective mass term. Well, let's go over the effective mass term. Effective inverse mass. Right, so to compute the change of the function, you take the current value plus summation of gradients. Use the constraint can move for that. There. So in this case, this delta Lagrange. Delta Lagrange is of mass indeed. C of x, which in this case, C of x. Oh, C of x is this thing, right? Oh wait, not this. This is technically, I don't actually have this, do I? Offset. Oh, it's offset by that. Right now I can just make it 0. In the center to the plane. Not just working with the plane. going through the center already. Okay, save that. So that constraint. This one is. We give that a b at 0, but it's going to be the delta eventually. It's going to. Without the what is it called again? I think what's it called? It was something to stiffness. Right. It was 1 over stiffness, maybe. This part. Compliance. Compliance of 0. Well, perfect rigid at 0 anyway, so this whole thing remains 0. This whole thing remains 0. Interesting. Interesting. If compliance is 0, both of these are zeros, so we just need that. Minus the inverse mass. Supposedly. It's kind of interesting. Well, so if I'm working with compliance term being 0, do I still need to accumulate the deltas? It doesn't seem like I need to. Yeah. Okay. So that's for fancy stuff. Okay. Of bodies and clothes, I suppose. Delta Lagrange. Fair. One over inverse of mass. There's delta Lagrange and the gradient change. So fine. The thing, this one already has. No, this should be a new position actually. This is happening after applies positions, right? I'm going to this. Could actually try this out and see what happens. What's out of range? Excuse me? This thing just dead. Huh, interesting. Whatever. On the ball. Here we go. Play normal, pointing up, position. Sphere radius of 5. Second strain is 15. Fine. Delta Lagrange. Minus 15. Wait, none of this should do anything if... Hold on. If constraint is positive or 0, nothing to do. Yeah. Let's wait until that constraint is that good. Still need to tune that size, huh? That's fine. The constraint is starting to be negative. Good. Total Lagrange. Why is the delta negative? See, there's message is 1, delta Lagrange is positive. Suppression is 1. I think one of them signs needs to be positive. Yep. Okay. Oh, it's right, velocity. I need to update velocity based on that change at the end, right here. Okay, good. 0. What kind of dimension is it then? Is it 3 or something? Is it 3 or something? Oh, messed up this velocity thing. I'll now have to know. No, need the same block. Really? It just comes out as 0? That's so weird. That one doesn't make sense. I guess that is very small, tiniest change. Oh. Is this wrong somehow? Oh, it is wrong. Oh. Ooh, that is no bueno. That is a bad bug. Do I drink any drinks? Water. Well, I guess it's first physical simulation, kinda. Did at least get dimensions kinda right. Kinda. Boom, it exploded. Stability issues much. Boom, it just went somewhere. Okay. Yeah, some numerical precisions here are definitely not happy. Definitely not happy. I need to talk about that. The step that recomputes the velocity has numerical issues. Doesn't it? Small steps, small time deltas. I mean, maybe for now I could flag it as something that was affected by constraints, but that still sounds painful. Less dv of constraint. Then affect velocity. Yeah, keep what's predicted by forces, keep what's predicted, keep what's after constraints. Okay. Yeah, substep, still something I need to do. Mm-hmm. Yeah, let's do that. Let's do starting position, predicted position by forces. Constrained position. Yeah. Need to go by predicted position. Right. Constraint minus predicted. So that gives me this. Now this is predicted one as well. Yeah. See if that keeps velocity a little bit saner. So it doesn't explode once in a while. Ooh. No, it still hates me here. Oh, yeah, I didn't. I need to reapply this. What time? Spawn a ball. Detect its position. Check. Right, there's nothing to solve. Oh. Interesting that it stops. Oh, velocity gone wild. Yeah, okay. Okay, now getting this velocity right. So if it's 0, it's going to be no change. What might be the reason why spheres don't bounce? Yeah, solid velocity is just gone. Just gone. Okay, so let's... First time it actually has contact. What happens then? The X of something that's going up. Then what kind of delta is it gonna have? Diff is way up high. Professional C++, I guess. Honestly, it's been a long time since I read any kind of C++ book. It's not particularly necessary for me anyway. So let me see. Velocity. It wasn't enough to balance it out. It just wasn't enough. It hit it a bit too hard. Yeah. After projection. Is that sphere velocity on a normal? I'm using zero compliance factor and adjusting velocity as that just eats it. The difference actually tells me in this frame there was a change due to constraints. So I could preserve some of that velocity. Some. Alpha 0, that is perfectly inelastic. Interesting. Yeah, and then let's go back to the compliance thing, this term. That term. Compliance factor is... There's also like bounce in this. I kind of like it. Self-spring-like constraint. Okay. Well, fine. Let's go and do that term then. Yeah, this part. Compliance. It's factor delta squared times that thing. Ignore that for now. Oh, do I? Actually. But this one. That can stay there. Lions factor. Ate it. It just ate it, man. Instantly slide give. Oh, this needs to be really tiny, actually, huh? I'm gonna just guess the right dimensions of this thing, huh? Fine, maybe it's 2 or something. What was it? Ball. Object ball. Okay, model. I don't even know what that is it? Darn. Good song. I suppose. Let's see. Let's put a ball. Alright, fine. What about 2? Yeah. Looks like it is radius of 2. Well, at least they're working. So the next step is sphere-to-sphere collisions. Basic sphere plane constraint. Now sphere-to-sphere. Why do constraints combine? All bodies are involved. The Q is a subset of bodies in the position X, okay. Right. A single scalar correction for each one, right? So same formula, you just add up the deltas Lagranges from each. No, delta axis from each, right? Yeah. Looks like I need a bit more light. Be right back. Almost like I solve each one independently. Yeah. Okay. Fine. Then let's do Okay, go back to sphere math. Let's give a plane if there is. So now we need to accumulate that stuff. Accumulate, okay. Right. No, it does feel like almost like there's deformation in there. Okay. Okay. I guess now actually I could just detect what type it is. And this way support neither more than one plane. Right, they should still work and collide of planes. Good. Good. Look at this, 12 reloads just for this session already. Okay. This out. Okay. Now, sphere to sphere. Distance minus. Makes sense. That makes sense. Makes sense. So here, third access. Distance minus radius 1, radius 2, right? Yeah. Positions. Positions. Which positions should I grab between spheres? Starting, predicted, constrained. I guess it's predicted. Right, minus. Right, still fine. Yeah, this part remains this. Wait, GC of X is a normal between the spheres, right? Gradient. Yeah, it has to be. Okay, let's remove randomness. Okay, let's go to correct that. Something tells me it might be something like this. Okay. I kind of want to experiment of 2 planes. Is what I want to do. What are you seeing? Ground position. Although the other option is just to have a huge sphere that's static. Okay. Oh, this needs to include both masses. Right. Right. This is both masses. That makes sense. It's time for a new task, new button. I want good, no explosions. That is a victory. It's up red. Today is a side project day. You know what kind of projects I have? Side projects I have? It's something where I suddenly create a little side scene in the game. So you can still have the full game on, right? But now I've built out the new physics playground where I get to implement my new physics engine for the future. Look at that. First collisions between spheres to spheres on a plane. I wish they'd constrain them in some way. But I don't have boxes yet. Do you have this? Boink. Okay. Doesn't have rotations either. Yeah. But it's fine. I don't want to constrain them. I guess if I don't want to constrain them, then I have to... Then I guess I have to introduce boxes. Boxes are gonna be slightly more involved. Okay, fine. Alright. How about a math for a box of rotation? This is gonna get probably a little nasty, isn't it? In it. Well, this is a good checkpoint to make, though. Sphere to sphere collisions. Here. Play my own physics, that's right. Extremely complicated. It's definitely involved to some degree, but honestly, on the other hand, I mean, look at what I already have. I got this, bounce around and stuff. And it wasn't that complex. Well, at least when talking to AI. At least when talking to AI. But such spheres and planes, that was supposedly the easiest thing. But oriented box, that's gonna be more involved. That's gonna be more involved. Or for normal rotation, half extends, right? Your center in a box local space. These boxes shouldn't go too far, maybe. Not sure. The nearest face. Let's do math for OBB versus OBB. Well, actually versus plane to begin. So at least I stop at the ground. Need my water is what I need. Alright, while I was thinking, I'm gonna be right back. Okay. Enter. Okay, X is A, I get it. Half extends, okay. For rotation R, okay. Okay. Line of normal of plane versus axis, okay. For direction, okay. Texas versus plane, okay. E is a center, R is support direction, okay. I mean, that seems reasonable still. Still seems reasonable. I think now I have to include rotation into this. Swine signs. Let's see, I have a solution. Wait, third one. World inertia, that's right. That's right. So the same. Why the 3 different points? Oh. Almost like it showed 1, 2 as an option and 3 as a conclusion. In box local space. Mm-hmm. The box is above the plane, touching a corner or whatever. Hmm. Right. That makes sense. 1 or 2. This for vertex versus side nav. Explicit vertex. That makes sense of axes. Okay. Okay, so let's start in the case of 1. Let's do just 1 for now for delta x computation. Meanwhile, okay. Get the box. Get that. Do you have a box? Surely have some kind of box, like a simple box. Number 2. Let's start with this visual confirmation. That shouldn't be going down there. Oh, we'd only do it here. There you go. Okay. That's a start. There's gonna be a bunch of permutations, ain't it? Ain't it? What's up, Adichie? Okay, that is the thing. Let's put it here. Well, the good news is that the balls are working. Well, that's a victory. Oh yeah, I should time it. I should time it. Keep it in milliseconds. Bum bum bum. Okay. Yeah, I mean, this is too simple, I suppose, to show up in any particular way. Unless maybe I want to go crazy. No, it's gonna explode. Fair enough, fair enough. Alright, I have sphere against plane, against other spheres. Now onto box. Onto box. Sure seems very similar. Right. Let's start with this one first. Right. Now the base, same idea. Yep, right. All same. This is against the plane. So the trick is this thing. That's the trick. Everything else remains the same. Then let's express it. Get constrained. Full box and plane. Well, I don't want to go too far into that. So I need rotation already. I need rotation already. Am I gonna need the same combination? Go velocity 2 in it. Let's find a start. All right. So first one is a sum. So I don't need axes. Okay. I have the axes. Right. Okay, fine axes. Box side axes. Okay. Okay. Of separation, what is it called? So sine. That looks like a dot, which makes sense. Versus one of the axes. Technically, it's called tangent. Fine. Think I have anything it's a sign yet. Sign you just either 1 or -1, right? Think so. SK. Sign is gonna do 0. Plane normal take perpendicular to one of box local cases. I'll go with that. Yes. Okay. So I can do this now. Put that of sign, get that. Okay. Math days. Okay. Now the summation is times. I am tempted. Oh, so tempted. If this is up, which means this times axes. Yes. That's a little bit weird to do it this way, to be honest. Let's rework that a bit. Okay. Yeah, it's less ugly. Oh wait, this is a vector. Right, so that computes the R. Hmm. Point is Y. C plus the R. Okay. Contact point. C plus R. Interesting. Well, I guess it kind of makes sense. Axes plus dimensions. Dot Y plus D. It's against the plane, right? Yes. C being the center, I'm pretty sure. Predicted. Right. Rate of X. Yeah. That's all right. What do you think is the best physics library? Physics 5 for sure. The one that I've tested around. The one that you have access to anyway. Commercial one's probably better, but never tried them. At some point, I even asked Havoc Physics to get a license on that, but it's only available for the big dudes. Big dudes. So let's see. Plain normal. Everybody. Normal times Y. Oh, D is the offset for plane. Isn't that same as position? Oh, no, it's not. It is not. I need to compute that. Okay. So that's constrained. Fair enough. Effective inverse mass. Now that rotational part gets a little wonky. New stuff. New stuff. Lever arm to calm. I have the Y. Yes, contact point. Rotational part. On even-sided box, the inertia is identity, right? Oh yeah, I need to take mass into account. Right. Oh, actually compute that, can straight up compute that. Shiner shit. So I'm gonna need math 3. Okay. It's time. It's time. Makes sense. Do I not have math 3? I only have math 4. I don't have math 3. Kinda want it. Kinda want it. Four. Why did I do 32 alignment? Did I do 32 alignment for GPU ops? I don't remember. Don't remember why I did that. Huh. Very concerning. But either way, that's just fine. Yeah, that's... We add in the body. Why don't you do that for other ones too? The mass. 1-3 mass. This is what? 3 vectors, okay. Going for Z, okay. Makes sense. Zero out everything in that case. And X and Y, okay. Now, is there a quick 0? Maybe even just say entity works, kinda. Do this, so we got ourselves that. I wonder how easy it would be to first do rotations for spheres, but since I'm already here, maybe. Okay. Fine, I got it, I got it. To here. Lever. Is it momentum or something? Center of mass. Okay, makes sense. Fair. Fair. So, lever, arm. Okay, got it. Okay, that's fine. Now, box versus plane. Compute this, I can put a constraint, makes sense. Now, effective mass. Effective mass. First off is lever, makes sense. Lever. Rotational part. Mass transposed. Let's focus on K-rod. Its units. And each I'm going into it. Contact normal vector. Excuse me? It's not plane anymore. Inertia, I got it, 3x3. Okay, I got that. Direction. What's the map for the contact? Normal for box, plane. Mm-hmm. So computed Y already, computed C, so I'm good. The contact normal, planes unit normal. Oh, that makes sense. That makes total sense. Okay, so I don't particularly care in that case. This is a cross, right? The cross times 3 times cross collapses down to a scalar k-rod. So let me see. In the case, this one is gonna be like against the other plane, like sphere against plane. So it's just plane normal, yeah. Box versus plane, good. Still computing the mass though. Go back into that. Okay. That I have. Post. It's a good question if there's even a operation like that already. Multiply. What sigillium operations can help of k-rod? If not, I just have to do manual. what I need. Let's see. Let us see if it is indeed what I need. Get that. I suppose. Given level and rotation, my body. The input. Wait, R is rotation. Oh. Because you build it in the world. Right. Right. Cross makes sense. Go. Seems kind of useful, actually. I'll take it. I'll take it. The rotation thing is. But for normal that to be constructed. This is already inverted, isn't it? Yeah. It's already inverted. Yeah. Inertia. I do inertia inverted already. Inverted. Because why not? Adding it. Such as here. Good. Good, good, good. That's that. Pass that in there. Good. Okay. Back to how to use Krot. Keyframe frequencies issues again. I'll have to look into that. Now that was for the math, right? Something around here, plus some else, plus some else. No, we're just gonna lag. Okay. Wow. Usually will lag. All right. All right. But all that is normal. Everything is fine. What rotation? Something. Something. Okay, this I'm starting to understand what he's saying. I see. Right. It was just inverse plus Krot. Okay. So it's fine-ish. Position solve. Wait. It should be 0. Okay, so this is body against plane, kinematic plane. So none of this. Delta Lagrange is. This one you doesn't have compliance. I guess that's fine. I'm efficient. Okay. So that remains the same. Solving for box versus a plane. Does this math look similar when it comes to this level? I guess I'm curious how this looks. How does this look without any rotational part? Does it bounce at all? No. No bounce. Want to see? Okay, going on here. Small one. Collision. That is weird. Waited way too long. Way too long. Oh, whoops. Yikes. That would help to do that right. Okay, that didn't fix it. Start from scratch in that case. Let's go. Okay, axes. The rotation shouldn't change it. Working on the R. An interesting R. First of all, I was expecting one of them to be 0. I was expecting one of them to be 0. Before getting into this, got a 1, which makes sense. And get a 0. Oh, biscuit. I knew it. One of the basics was way off. Do we ever get to this? Just in case. I mean, you're not. It triggered one halfway. Interesting. Computing constraint. X. But the C goes negative only. Crossing over the center of mass. Meanwhile, Fine, half axes should be okay. That. Group my dimensions. Probably 1. I'm not even sure. That might be a problem. It's 2 on each side, so never mind. That part is fine. Wait, so that... What am I computing? Oh. That is what I need. Dimensions for the R2 makes sense. Now this makes sense. It should be just vertical up or down, fine. So then Y is... I think that should be negative. It should be -2, not +2. Which means somewhere here. I don't know if I need invert or not. Where's my breakpoint, bro? I need my breakpoint. Here, 1. Yeah. We're pointing that way. So that surprisingly did not change at all. Quite surprising. Oh, what time? Axes. Dimensions. So for the up vector, the sign is -1. Fine. Now that's a 0. That makes sense. 0, 0. Interesting. So it's not even that. It's almost like I want to flip this somehow, but I don't understand why. Fine, force limited -2. Okay. So the Y is at 18. That makes sense. Constraint of X. Some big. Fine, let's go. Hey, now cut up a bit earlier. Good, good. Cut up a bit earlier. good. 0, which makes sense. Okay. So then it should at least bounce. And it's not wanting to bounce. Oh, mess wasn't set. That makes sense. That makes sense. Now this one looks almost like it's working, except it flings the wrong direction. I'm having to do this nonsense again. Box versus plane. Okay. Fair enough. Fair enough. Alright, that's whatever. Total computed. Okay. Hard contacts. The position rotation changes. Total Lagrange computed. That'll be this one. Okay. Okay. So then delta the position. So this portion, I need mass factor. No, this one's inverse mass. Times delta Lagrange. Oh, so this one is the same. So that doesn't change. What does change is rotation. Rotate a small angle. Focus on rotation update, whatever it's called. So mat 3 here. It is. Because mat 3 was the input. Theta, I see. Theta, inverse matrix for mass. Lag cross, that and N, okay. Okay. So, theta, inverse, correct. Mm-hmm. Mm-hmm. Which I guess makes sense. Get the cross off. Lever and right, then multiply this thing by the delta Lagrange. And then multiply the whole thing by the matrix. Inertia inverted by this dude and into this. Okay. Fair enough. Correction vector. Yeah, and then forming up this. Or delta. Mm-hmm. Mm-hmm. Or delta indeed. Excuse me? It must be in inertia, right? Not. Oh, it is. It is identity. Focus on R new. It is identity. Not adding to it. Really? You have to manually edit, I guess. I guess makes sense. I was surprised. Got scale, doesn't have add. Okay. Fair enough. Wait, if this is just... If they just identity, what if I just make it 1 and call it a day? Into, where's my source? This one. That's my nude. A separate one too, wouldn't it? Wouldn't it? Maybe, maybe not. Ortho. I guess we're normalizing the quaternion. There you go. Yeah, I do a bunch of characters here. Okay. If you prefer quaternions. I prefer quaternions. Exact Rodriguez. Wow. Wow. New rotation, new rotation. Sure, we need to multiply together. They keep. Guess for now I can try to 1. Rotation. Rotation. Means it's time to apply it back out. No, Mr. Oh, boxes don't bump against each other yet. Okay. Can't quite test rotation then until I have box to box. Unless I start rotation. Yeah, let's do that. Maybe just pass it as this. Just pass it as this. Gives me rotation, right. Now give it some rotation. Oh, I already forget. Gonna retain rotation. Left multiply. Occasionally. Okay, that's fine. Controlling values for rotation around the 45 degrees. Am I applying rotation? I thought I was, but maybe I'm not. Box against plane. New rotation. Technically at 45, I might be even bounds. Let's give it 40 in that case. Actually, I'm too lazy. That's dumb. No. Let's use the brain a little bit. Just a little. Box. Okay. Your rod was an actual thing this time. Good. Get the temp. Play normal lever. Skill down to infinity? Jesus Christ, Lagrange. I guess it's kind of small change here. Now it's kind of big. Yeah. Multiply out into theta. Point of weight. Rotation. Rotation 381 versus this one. 3493. There's actually a difference. There's actually a difference. I see the difference. Even though we ain't doing it. Oh. I gotta see it. It did flip for a little bit, and then it was wrong. And that it was wrong. I wonder. I wonder. Oh, it just, I get it. I'm just missing the rotational velocity. Same thing again. Rotation predicted. Constrained. Yeah. Why does it take so long to run through that crap? Total delta rotation. Actually, I'll keep with Quaternion. Which I think by default is, yes. Whoops. Okay, rotation constraint, that makes sense. Yeah. Which means I need angular velocity. I keep rotation, angular velocity in quaternion. Sphinx, maybe? It's a 3-vector, fair. Good. To compute quaternion, change from where, like 3 velocity. Oh, right, I need the whole mass as well. Yeah, that's fair. Tanzerai. Your velocity, rotation times step. Normalize angular velocity. The angle. Did I just gain length or something? Yes. Axes. Bro. Quaternion by angular velocity of time. But what does that actually return? It keeps doing it. Euclidean norm. We'll get magnitude of a vector or whatever. Euclidean space. Basic length, isn't it? That's length squared, isn't it? Ain't it? It's length squared, man. Yes, we'll just length. It's literally just length. Really? You can use axes just like that? Why do I have... Bro, axes are just normalized. Yeah, just normalized. Come XYZ is angular velocity. Becomes a scaled axis of rotation. Bro, you already said to me it's today. Chill. Fair. Okay. Okay. Short method to compute new versor from vec3 angular in delta. Seeding, but don't know where it's coming from. Oh, he really creates cursor from that. Okay. This looks very similar to computing quad from angle and axes. Borja. They've won GPT 5.1. Boom. If I do F5. Suppose. If it out updates, maybe. Oh, there are any problems. It's already way too nice anyway. The same math, yeah. Oh, really? Really? Look at that, I got 100. That's so funny. Position changing per second. Say I already have. Bit of velocity. might be reasonable. It might be. Oh, flip it. Flip it. Okay, back to rotation, except it's here. Delta. Rotation. Angular and delta. Rotation predicted. That seems reasonable. That seems reasonable. Which means so we go into solid constraints. Okay. This is not used anywhere else accidentally, like here. Box against plane. Still somewhere here. Okay. That's fine. That's fine. Okay. This might be something. The box might actually turn out. There's a chance. If I got that math right. Dun. Not quite. No, it gets completely ignored. Rotation constrained. Delta rotation. Wait, I don't compute angular speed from anything. Angular velocity. Make the math on computing angular velocity from constraint. Boom, boom, boom. Linear velocity, angular lever. Yeah, that's how I computed it up to here. Hold on a second. What was I computing this? Okay, route from contact. Yeah, computer does here. Yeah. We have that. Some mass factor, I have that. So I have the effective mass. Mass effective. Plus magnitude. Trained of X divided by mass effective. Wait, that was for positional, which I already do that way. That looks very similar to this. Except sort of leather. Isn't that delta theta? Like computing key rods, but instead of lever, it's J impulse mag. Key rod and J. Oh, because I don't compute on that last part. Cross between has it. Nice times that the inverse magnitude. Inverted destination. Wait, I think this goes into vector. Yes, okay. It seems reasonable. That just gets applied to. Okay, okay. Okay. Hmm. So does each constraint apply zone angular change? I guess so, right? Oh. Angular change. Velocity change? Wait a second. I need to compute the product of rotation changes from all constraints, and then against the starting rotation, compute the angular velocity. Five hours already. Jesus. Jesus. Because I did that of position, compute differences, and then from that. Well, it does compute the angular. Oh, it's gonna pause it again. But a constraint computes the angular. What? Vector angular velocity. like 3 computation. Was that velocity or rotational change to satisfy the constraint? Supposedly that does it. Supposedly. I'm gonna keep that as to do. Blazing fast, well, he kind of when decides what to do it, which path to use. And on top of that, I don't know why it either just doesn't respond or just lags out for like, I don't know, half a minute while it's thinking about things. Not sure why. All I know is that you just wait long enough and it wakes up. To the Mokatronian math to do that, if this is true. Tall delta rotation. Dish. Rightish. A small angle of vector takes about to satisfy, right? Small function to compute the velocity from before and after quads and a delta. Oh, nope. It's gonna be busy for a while. It's gonna be busy for a while, but rotation, rotation, rotation. Here I ain't doing nothing to that. Nope. Bro. Starting makes sense. Okay. Yeah. At least just follow and be flipped around. It's progress. It's kind of funny. Oh, attempt to actually compute the actual velocity though. Quaternions and DT. I want something Similar to how I did velocity, linear velocity. To keep numerical issues away. Unions, conjugate, fine. That's difference. Axis angle. What are you gonna divide the angle? Small angle. B. Keeps pumping. Keeps pumping. Right. Velocity from quads. Pum 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 pum. Let me guess. Conjugate. Sure. Don't have a C1 either. Kind of lame. Do that though. What's up, gamer? From predicted to constrained of a delta. Welcome to the day of math. The day of math. Late night, I guess. Just over 5 hours. Alright, let's do real compilation. Welcome to physics coding. Oh yeah, baby. That's what I'm talking about. Vibe coding. It's a vibe-ish. How about that? It's a vibe-ish. Dun, 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 dun. Looks fine, indeed. Indeed. Okay. That's velocity. I need to see angular velocity. That's what I need to see. Line GUI. He just goes wild. It goes wild. Okay, I want to see the first time that gets computed. Dun, 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 dun. First time here. Okay. Good contact. No angular velocity at all. Good, good, good. Rotation. Seems kind of minor and quiet. Fine. Predicted. Constrained. That's a big, big rotation. A bigger rotation. 18 seems a bit much. A bit much. Buy it. Something gotta be a little off. 25. Let's drop it somewhere smaller height. Box. Oh. Just have a start coding from childhood. Yes, that's correct. Dun, dun. I'm pretty sure the first computation is wrong. But it's fine if it goes wild, I guess. Well, it might be time to start throwing code at it. Cross. What about almost nothing? Indeed, yeah. Yeah. The fact that it's doing that bothers me. That smells like just wrong rotation. as a constraint solution. Alright, it's time to continue vibing. It's time to continue vibing. I just throw this code at it. In my box, point code. Suspect that rotation outcome is incorrect. Now I'm gonna have to wipe pretty hard of the math part. Pretty hard. Dun, 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 dun. I mean, I can just blindly toggle up some stuff. Yeah, that was definitely wrong. What seems... Invalid inputs. Oh. Yeah, probably gave it some bad rotation. Oof. Oof. What's up, Elfman? Let's destroy that one robot and then back to physical playground. Back to physics. Yeah, I used to work at Microsoft a long time ago. Okay. Now back to Wild Box. The box is not to be tamed until it explodes. Kernel, no, Windows Server. If you have Windows, fire up one command line and type 1rem. Windows Remote Management. It's kind of the old school way of controlling and setting up your machines before new PowerShell and other things. It ships as part of Windows Server and all Windows machines. Ugh. Oh, WebDev, that thing is dead for a while. Fine. Let's go back to rotational stuff. I thought I did good here. Rotation. Oh, wait, this roll rotation. Oh, it already computes off of predicted. Oh, that would be a problem. What I feel about modern day Windows? Still better than Linux. It's about as well as I can say. But yeah. If there was, I actually have a dual boot Gentoo Linux, but debugging tools are so pathetic on Linux, I just can't do it there. I just can't. Visual Studio is just too good. If Visual Studio ran on Linux, I'd switch to that, but I ain't giving up. I ain't giving up this. But hey, if anything, Windows probably has more stability today than it was in the Windows Millennium and a few other systems, so it depends. Well, I wish it ran debuggers in a decent way. All right, I understand what the problem is. I'm going here for rotation. I think here actually I need to compute difference. I think I know what it is. Yeah. Oh. Well, that's a minor thing. Oh yeah, I was. Jesus. Jesus. That's a good call. Windows 11. I haven't had any problems, to be honest. The only time I had problem was I installed a preview update. And then we had a crashing taskbar. Outside of that, last 5 years, I was using Windows 11. I haven't had any issues. There was like once slow down initial. There was like a pause for like a second and a half to 3 seconds when initial Windows startup. Sometimes after login screen. But outside of that, not a problem. Taskbar on the right, yeah. Well, it's too much. That's too hard to do, man. We've lost that ability. Yeah. But slower otherwise, I haven't noticed any difference. Like when I run my game, it runs just as well on Linux does on Windows. Well, Windows 11's been out for a while, right? So I think I've used it for like 5 years. Let's remember switching to Windows 11 about 5 years ago, so for me it's been pretty quiet. Yeah, summer is fine. Yeah, for some reason I need that minus, not sure why. First update. Well, yeah, Windows 10 is out of service pretty much, so yeah. Yup. Hey, maybe you can go make Linux a better desktop environment, because holy crap. Linux makes Windows look good. Especially on tooling. Such nasty tools. That's basically it. Linux is such a pain in the ass to use. The only engineers have enough patience to use it for servers. So yeah. At least with Gentoo Linux, I was able to just build it from scratch. So it only has the stuff I care about. But I have to wait for some good debuggers to come along to use it there. It's no nasty. Xcode. Yeah, Xcode is not much better. I've used it before. But yeah, debugger is extremely important tool for developers. I don't understand why Linux people don't do it. All we do is use nasty console-only command line debuggers. Those things are disgusting. Just disgusting. I don't know. For some reason, this wasn't working out last time. Let's try it again. Boink, boink, boink. Let's go. Clang D, I guess. That's the funny part. Like the best debuggers on Linux are coming from Microsoft. It's just silliness. The fact that they need visual code to actually be decent debugging UI, it's just sadness. It's just sad. SignPass, I ended up having the contact point and axis pointing up instead of down, which is why I flipped the sign. A bit PMs. Well, that's true everywhere, dude. That's not a particularly special thing. Having worked at both Amazon and Microsoft, PMs are always bad. The funny part about going to Microsoft, as I've watched PMs come up from day one, where they literally just got out of college, day one, they're PM. And you just watch them like in real time learn the language of BS. It's something else. It's something else. Yeah, like why is it ended up being plus? Well, it should be minus. Yeah. Well, even the best of them who are not pixie cuts are just as bad. Just as bad. So let's see. Play normal. Play normal is supposed to be up. It's supposed to be up. And the axes are... The first one is up and it's pointing up. Dot should be positive. It really feels like it should be negative. This rigid bodies, yeah. Apply a round of, this is a side project. Oh, that's funny. What are you doing under? Oh, I'm just doing that. Usually I'll be working on this portion of the game. The one that's been more or less built out. Currently using Physics 5 for physics, but once in a while I get an urge to have my own physics. And today is day one, just tinkering of some basic physics code. Indeed. Are you at spotting me, little dude? No, I need to work on this guy too. I need to work on that guy as well. Well, 4,000 lines is nothing. That's peanuts. For game dev, that is peanuts. That's a weekend. Alright. Back to here. Let's see. Because to me, it seems like... Because we have upside that. So up is plus. Which means the sign would be positive. Because it's going alongside. Which doesn't make sense. Writing Jai. I mean, compile time would definitely be nice. My worry is that Jai people don't particularly care about visual editing, visual debugging, so I don't know. It's gonna be really hard to give up debugging like this, plus all the IntelliSense and so on. And those people, Jai people, don't seem to like IntelliSense at all. They prefer to write code, hard code, without any kind of help. Yeah, I mean, that's the other thing I don't particularly like. Because if you have the editor outside of Visual Studio and using that, so debugger might be kind of doable. But IntelliSense thing might be a problem. Because I'm using Sharp C++, and that thing gives me so much that going to a language without all that, I don't know, might be tough. Yeah, I'm gonna still keep it one negative. Well, somebody working on IntelliSense is not gonna be good enough. I need a professional IntelliSense, not like a little open source project somebody wrote in like in a month or so. Proper useful IntelliSense, dude, takes a few years to build up. But yeah, we'll see. Eventually will be good enough. No worries. But that's a first world problem. Once I make a bajillion amount of money, then I can do whatever. And then I can do the jive thing. So I think this one is still correct. So let's go back to here. Small angle update. Back to correction on 3. Is I identity? Oh, inverse mass. Visual minus Microsoft? No. No, I don't. I was a bad employee in the long run. I just wasn't particularly interested in your work there. I got through enough to learn some C++, but eventually was like, do I need to go switch into video games? So I didn't grow that much there. Identity matrix, fine. No, I was working for Amazon. That was a lot more fun. At least then I worked on game engines in some games. That was decent. Well, Microsoft was mainly waiting out until immigration, plus some basic skills. Isn't this 1 plus Q? That's what I figured. That's why I threw one in there. Fair. That I couldn't understand. Alright, let's throw it. Keep on vibing on the math part. So, assuming, so back to it then. So I think this one at least kind of makes sense. R is what? Yes, that makes sense. Contact point 2.5. Yeah, that makes sense. See, at least contact, I get the contact correct. Just rotation after that. The one is still fine. think it's coming somewhere here as a real problem. Itself is somehow wrong. It's a new rotation. Wait. I think this is already full on. Is it not? No. I think it's already global. Hold on a second. Lost rotation somehow. Somehow has lost rotation. Something. Yo. Oh, I lost the body. C index 1, rotation, starting, predicted. I expect it to be about the same, and it is not. It's not. But I thought I computed this here. Now, let's go here. Predicted, got it. Constrained. Oh. Wait, what? Where did this go away? This one has rotation. This one, so that's 2. Oh. Oh, yo. Yeah, that makes sense for it to be a problem. Problem is, let's compute that. I think I need to do the difference actually. Yeah. I think the issue is I need to compute the delta rotation from the rotation we get from the constraint versus predicted one. It's the real answer. That's a new. Predicted and new rotation. Yeah. From Q1, Q0 to Q1. If Q. I think that's a real answer. Delta rotation, make sure this comes out as identity. It should. I like this more. Fine, restart. Now, go to here. No. Back into it. Into crash, perfect. Love it. Ooh. See a bunch of nans. Yep. Yep. Extra drawing is on 0. But anyway. This isn't really right anyway. I don't like it. Right. Small angle. Oh, I can turn it directly into delta quaternion accumulated. Yeah. predicted. New tech rotation. Right. Huh. Shortest arc. Interesting. Interesting. Gets right every time. Okay. Before compute the 1 plus q, and take d theta and compute delta quad from it. Dang, negating quaternion at least the shortest arc. Interesting. Yeah, it certainly looks like this one is a small angle rotation matrix. So I don't even need to compute all this. And just convert that. Delta. Well, I think that at least looks correct. Now I think I might be able to work on angular speed. At least the angular correction is no good. Yeah. Alright. Alright, I do need a checkpoint though. Now, maybe now. Honestly, just save this to compute angular velocity. Yeah. But for now, actually, since I know this is fine, I really should just do it. Rotation delta constrained. Boom, it's happening. Good. Okay. Yes. Now. It seems like it would do it. It might. Hey, yo. That looked like in the ballpark of being correct enough. Okay. Now that's the easy part is done. Dude, give me the mouse back. Don't be like that. God damn it. Okay, we're back. Mouse is back. Good. Yeah. So much for that. Makes sense. Oh god. Time for box-to-box collision. Okay, got that working. 1, 2. I need some water though. Be right back. Okay. Box versus box is gonna be fun in the bun. But amazingly, it actually kind of works. It looks realistic enough. Bum, 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 bum. How reliable? Where is it? Let me see. Box. Oh, I do have a little bit of this. Does it always tip over? No. So much for determinism. Yeah. So now I have a box colliding of a plane only. Now I need to have them also collide against boxes and then against spheres. It's such a different technique compared to regular rigid body physics. Maybe just for fun, I can bump up. What was this term? Compliance factor. Oh yeah. Rip, rip, rip. That's gonna bounce for a while. That's funny. Similarity to its physics, yeah. Once it's all at least kind of understandable, there's plenty to do on that part. It's fine. Yeah, because this is positional base dynamics, so it's a bit of a different beast. It's supposed to be more stable. It's kind of funny the way it does it. Boing, 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 boing. But this is more over just the way it reacts to constraints. It's not really doing that, but it's kind of interesting the way it works. For sure. Yeah. Or I could just... I think when I give it 0 entirely, it just loses all the inertia. Yeah. I do already have ball to ball, but these guys don't rotate at all. But they do bounce against each other. That was my first step. These guys don't have rotation yet. That's something to do later. Oh, I to back to vibing onto the math. Math vibing is what I'm doing. Some coding a little bit. Oh, so also have a new change. And also keep track of how often I reload C++ code of hot reload. It's already been 120, I think, for today. Plus 9 for this session. If I reboot, it's going to be 129. Just play around with that. No, just for funsies, I'm gonna keep it on a down low. Maybe not that crazy. Do that. Just to kind of bounce around a bit. It's almost like it's in water. Almost. Oh. Oh yeah. Rip. Rip. It's definitely can be almost like a water thing. I'll take it. I'll take it. Dude, this one is thinking a while, but this one. Yeah. Because this one was primarily initially made from like spongy objects and clothing, whatnot. So hopefully with this in the future, we'll be able to have CPU simulation of clothing. And then if need be, I can even go GPU route in the future. We need to do because that effect of like being able to like drag click and drag, so I can just throw them around a bit. Although, before I can do that, I need to be able to do raycasts. I don't have any raycasts implemented for this physical bodies. Boink. Is anything more fun to do? No. Some of the stuff is just weird. Yeah, I don't have anything that looks good in a square, huh? Huh. Didn't I have... I guess I just have to... Built-in raycast of your own header. Yep. Well, it's not that. It's more... right now I'm using PhysX 5 for raycasting, but in this scene, PhysX is off. So there's nothing for me to cast. I could do that myself, obviously, but one thing at a time. Because I need the whole spatial division, supporting intersect properly and so on. Okay, let's get to some real business. Box versus box. So I have two boxes. A and B. Yeah, I understand that. Two centers, half extents on each. Get some match kill CPU, yeah. Suppose. I actually do some of the casting even on the threads now. If I have two milliliters going on, I put some of them on the thread. I think for player, keep it in the same frame. For robots, a delay by a frame. I mean, obviously, if I have my own physics code, dude, that opens up so much optimization. It's not even funny. ROBB between two K and K. Assign separation. A and B minus distance. Oh boy. Build candidate normals. The good news, I already spotted a few other videos how to do space hash, and it'll be interesting to try. That maps into a linear array. Because right now I'm just doing hard-coded. Check against everything. Not hard-coded, but brute force. So half extents. What's up, Ricardo? Did I build an engine front end? I'm not sure what front end means. But yeah, this is my own tech. My own renders, my own animation system, my own ray tracing. Not my own physics yet. That's not available. That's still in progress. Boink, boink. Here's a quick preview. Yeah, but today's a day of side project. Instead of working on the gameplay like I would be on this or something, we're using different... Oh, these guys. Hey, we're not gonna hit. That is a mess. Just full on destruction. Oh, these guys are still alive. Charge up. Hey, I need to do like day of bugs, but right now, playing around, see if I can build my own physics engine. Ooh. Oh, the restitution made everything bouncy like crazy. These guys. I see. I see. So they should go back to more or less normal. Actually, if I do it really small, how does it look like when it's boink boink? Ooh, it is not happy about that. Interesting. If you make it too strong, it will freak out. All right. Back to interesting stuff. Box versus box. Alright, AI. Time to understand the math one more time. For any unit test axis n. So this is against one of the boxes, against an axis. I'm guessing against the axis of the other. So given... Yeah, this gives the direction of separation by the axis for a given box. Okay. And the sign separation. Fair. And then test penetration there, array. Test to see, yeah, 6 axes makes sense. Do I use IMGO? Yes, that's right. Of course. Hell yes. Hell yeah, still got the demos. I don't think I will ever be writing my own IMGO. I'm fine with that. Also, I'm using IMplot. As an example, I have this audio editor. Hello, sound editor. Bro. Oh, this is that mode, so it's not gonna have, yeah. Here's some sound editor. For example, here I can select which part of a sound to play.
Hi.
As opposed to...
Hi. 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 Hi.
And then I think I can do a little fade out.
Hi. Hi.
Maybe not as much.
Hi.
It's more useful on the door. Yeah. But back to physics. It doesn't go too wild. Now, did box versus plane. It's time to do the hard part. Box versus box. Box. It's just being weird. Intel Sense letting me go this time. Letting me down. Alright, so I get it. So get all the 6 axes between 2 boxes. Compute these guys. Okay. And penetration for each. Separation axes. Got it. Got it. Pick the max. The maximum. Okay. Once I pick the axes, 4 points for A and B. Okay. Okay. Can't take position, midpoints, sure. Strength gap. And the rest already did kind of bunk versus planes. It's not too new and different. It's kind of reasonable. I can do it. I can do it. I can do it. Big sound mark. Okay. Build the access choices. Right. Mono. Okay. Each one's gonna have that. I mean, hell, I might as well do this twice. Or do explicitly keep it? Hmm. Actually, probably fine. Probably fine. Upper body habitation. Once I have multi-step, I'll need to compare against rotation predicted. For now, this is fine. Okay, that gives me that. All the axes. Yeah, that's a lot of computation can be for sure. Okay. That's fine. Projected radius. Yeah, that I'm probably gonna put in a function. Get projected radius. Okay. Now this one is gonna need half height one side of the other. Darn. Dimensions check against a normal 2 check. But specifically, for dimensions of first. Axis A. These are the axes and N. Okay. Just a dot. Center B. B is the other one. Penetration. Penetration. Gonna need this. Oh, I just pretend I'm inside a loop. Edge axes. Improve coverage. Okay, that's cute. That is cute. All right, let's do this guy. global. I was kind of hoping this would come out as three, something like this. This would be axes, axis choice, and the first one is what? Dimensions. Okay. Okay, sum across all three. Right. For dot between the x's given and an axis. Axis choice, yes. Name is about right. Now, what do you need here? I need 6 axes. Maybe I can just form them up as this and just not care too much. Playing past the end is correct. That is quite correct. Okay, now it's fine. This, look at that. This choice. No, it's not gonna fly. Using whichever biggest one. Less than 0, no contact. Hmm. It's already used somewhere, no wonder. What's this box? Just want to see if this makes any sense at all. Okay, time for 2 boxes. 2 boxes. Okay. Nutrition 4. I'm kind of hoping to see a frame. Not gonna show me a single frame. It is. Okay. 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 That's no bueno. Oh, this thing. Do it again. I was hoping. Ah, yes. Okay. Immediately thinks. Actually, this might be just visual difference. Let me see. The ball is spawned is a radius of 2. So these guys probably need dimensions of 1. Probably. Actually, I guess 2 makes sense because it's not a half. Then I need to make it a half. Body, have dimensions. No. Okay. No collisions yet, which is fine. This shouldn't be happening right away, except it is. 2. Okay. Maybe. Let's do it from scratch again. So spawn, they're like 5 points apart though. Patrician says 2. 0, 5, 0, 10. Makes sense. It's 5 points apart. Rotation predicted, fine. Data more or less believe. Have dimensions. Let's say access choice. Does this mean its length? ROBB formula. Yes. What do vertical lines indicate? It's already a dot product. Right? Was it supposed to be normalized? Oh, no. It's already absolute value. So in that case, I'm fine. Times half dimension. Direction. Fine. They indicate the absolute value. Oh. Yeah. Okay. That makes sense. All right, so now that's an important thing to know about math. One more time. First one. 5 points apart. Makes sense. And 1. That makes sense. Absolute value of distance. Oh, that needs to be positive. Absolute as well. Which not sure if it was. Okay. 4.8 penetration. Ain't nothing. Sun separational axis is 0. I mean, that makes sense. Because one of the axes be exactly the same. We choose a normal direction, so it points from A to B. Test 6 axes. Penetration of 2. Isn't positive means there's penetration? Computing penetration. Return positive on the axis where boxes overlap, even though in 3D the boxes don't overlap. It seems like you need to have a combination of them together, right? Overlapping along ends, I think actually makes sense. More questions on math, need to hurry it up. Choosing from A to B, fine. Contact points. I understand that. This makes sense. But what do I do with this one? I guess whichever. Well. Additional terms, yeah, this I understand. I think it will be more or less clear. Not to worry about that. Getting normals, yeah, that's what I did. Axes. Then best end from A to B. Distance, delta. Bruh. I guess penetration is not yet enough to really answer it, but just that maybe there is. So that makes sense actually. So fine, let's say I picked an axis. Low, it's really gonna be the way. This will be always be valid. So fine, I picked that. 4 points along the normal. hell, cold as hell. The center contract points, okay. Fine, fine. That's the center of the first one. Then the axis time. Yeah, usual sign. Sign off. Between picked axes. Well, that I don't quite understand what the pick comes from. Oh, just choosing a direction points one or the other way. I understand. Okay, okay. And this one, you want point into B. Let's see if dot flip if it's less than. Pointing the axis towards other body. Think so. Yeah. So I got the axis. Times the axis. Oh yeah, because it's that. Sure. Times I have height. Okay. Finally, the axis. Okay. This one isn't. The other one is minus. Interestingly enough. I guess it makes sense. I guess it makes sense. Contact position. Strain gap. Finally. Finally. Array. Array of n. That sure sounds like this. Salute off the distance, like, right? Yeah. And that's just that's box vector. Yes. Now have dimensions. All this just to be able to say constraint gap. I think if it's negative, it means it's not fully constrained. Okay. Contact position. Okay. Boink, boink, boink. 010, 05. But it's so far apart. One, one. Train of 2. Which means it's Gucci. Which means it's Gucci. Immediately. -28. Now dimensions of 1. These axes are fine. This one is fine. 1, 1. Box vector of 5. Wait, that doesn't make sense. That doesn't make sense. Trying to understand the constraint formula. RAN and RBN basically are value of how large a box is when projected onto the chosen axis. Is it? If so, then they would be less than the distance between them quite often. Thus leading to incorrect C. Right? They overlap if they overlap. Yeah, so negative means separated. Why did I think? Is it always like this? This one is a bit different. It's just not quite right. Okay. So what did I choose? Picked axis. That makes sense. 1, 1. Hmm. This picking axis thing might be the problem. I'm picking the axis. If I pick the largest separation, penetration, that might be an axis that points perpendicular to the other box. The one of minimum overlap. Wait, was I looking for the wrong one? Just save it off. Need to see. Go. What do we got? What do we got? Couple axes are positive. Wait. Looking for smallest? Okay. That makes more sense. Because some of the axes don't overlap, so it's fine, which means this should skip out till we get to here. Here at least. At least here. Okay, now everything is in the positive. So better than have to draw here anything interesting. Hmm. Hmm. Why do they immediately intersect? Box vector. It's still really freaking far apart. Hmm. Yeah. Because the first one is a negative one. The one is positive immediately. There reads. Wait a second. Wait a second. 010, 05. Next time 05. 010 is still the same. And yet. Bag got changed. Protection predicted. That is odd. Our body 010. We changed here. Go to here. Okay, going back to the boxes. So what changed this time? Rotation predicted. 1-1. Oh, I didn't sign this, did I? Of course. So supposed to be the sign. Yeah, it has to be. Okay. Yes, correct. Okay. That's progress, but I'll be right back. Darn, could code more. Yeah, I'll keep going. Okay, so the progress was made. We have. Let's see what this context ends up being at. 3.8. Fair, fair. It seems to say. Maybe just dimensions don't quite match up. Alright, fine. Back to math. Which means I have this. What's up, Doomsday? Biggest challenge so far as a game? I mean, this might be one of the biggest challenges. Writing future physics engines for the game. The only reason I can get through any of this is because I'm following AI's math with a lot of explanations. Luckily, I do have Physics 5 already, so I don't have to have it. Don't have to have it. But in the game, really, the biggest challenge is always to actually make the game fun. Technology and all that stuff, that's pretty easy, to be honest. It's like worst case, you're stuck on that for a week or two, fine. But making the game fun, that's always the real task. Boing, 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 boing. No. We have constraint. So where in the hell does it actually intersect fully? Is the answer never? How is it possible? Fine, I'll just restart. No, so I'm doing this full time. I've quit my job in the past. In the past, I used to be a game engine developer, whatnot. Always, even now. Constraint is something bigger too. Box vector. I think constraint here means the opposite. Make it means the opposite. If it's greater than, it means it's time. Hmm. In the past, also took me like a week to implement physical hair. That was definitely a challenge for a full week. I'm not sure I agree. Because now constraint seems like it's been flipped. Seems like it's been flipped. It's gonna take 5 minutes for you to process this, but you know what? Sometimes you gotta do it. Actually, wait. See. Gap pointing greater than 0. Doesn't make sense though. Negative we solve. Yeah, if positive, it means there's nothing hit. Huh. No more questions first. Its projected radius is just a scalar. How are we using it as a range overlap check? Projecting two boxes onto single axis. We need two values for a range. Axis, each vertex produces a scalar. Wait, is it supposed to be absolute value? Yeah, I got it. The projection center is right. Okay. So it would make sense, but then positive. So it makes sense now. Actually, constraint. 0.13. And this gets bigger. Makes sense. Makes sense. Up to 2. Right. Okay. So over 0 means that. Okay. 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 So two interlopes overlap if the biggest one is of the minimum and the minimum of B is below max A. Right. Then plug in the compact form. Kind of has them flipped, I think. Kind of has them flipped, but might get the point. Kind of has them flipped. Yeah, okay. Fine. Okay. Okay. I'm at the point finding constraint to be positive. Means that 2 boxes do overlap. Onto computing position rotational outcomes. That means following what I did here. Doing this way, but twice. Twice. This is gonna sleep for a while. Normal, I think. Wheel. Might as well. Effective mass. Lever A. Lever B. Right. Oh. Keep it from contact. Wait, this needs to be different. Sure. But this one. There. This is probably just the chosen axis, right? And that actually works out. Can I go to that? Nope, of course not. Of course not. Picture. Okay, that makes some sense. One of them have to be negative, probably. Additional updates. Start that. Point, got it. Greater than means overlap. Let's see. Good mass. That's fine. Effective and mass. Oh, wait. It's effective thing combined. Combines it. Okay. Interesting. Effective. Okay, so that delta is shared. Okay. This one is shared. Okay. One of them has to be plus. No minus. Makes sense. Makes sense. So let's do. Oh, not yet. Oh, you apply it to the other body too. Not to the other body as well. Interesting. Interesting. Wait a second. Wasn't aware of that. Okay. So the constraint resolves both bodies. Contact. Hmm. Hmm. Well. Hmm. Let's revisit sphere in that case. But interesting. Interesting. It means total delta needs to be computed on the body. Hmm. Yeah. Oh, maybe the way I would do it. Yeah, that I can do. I can do this. Excuse me. The A. Which one is B? Which one is A? Oh, don't know. But A was its own. I guess it's a first interaction. I'm curious to do the other way around. This sink really hard into the ground, huh? Huh. No, where? Okay. Okay. That's more reasonable. Now. Yeah, I thought for sure it's gonna be the other way around. Pretty sure this caused an explosion. Yep. Sure does. This one seems more reasonable. Now, back to doing rotations. Rotations. And that'll be this thing. Now this is picked axes. Axes. And this becomes the A. Yeah. This is going into a function real fast. This whole thing is... the A rank. Got that. Probably negative somewhere. Under B. Get the delta. Except this one is... constrained. Really? Is it just time to implement this thing? Why the other one? I feel like this one needs to be a negative or something. Well, no, not that. Correction vector, or maybe this one. Yeah, that looks... sliding around is funny, but it's fine. Must have more boxes. More boxes. Boink, boink, boink. I do like to explode a little. This really day one? Yes. Yes, it is. I'm thinking vibing AI helps a lot, actually. If you can handle reading all this math and so on. Hooey, dude. I've been drilling AIs all day. Look at all this. Almost no code, a little bit of code once in a while. But then it was math, just a lot of freaking math. Okay. Oh yeah, this one. Equal and opposite corrections. That's what I wanted to have. Because I think, because what I actually started with was just balls, but they don't have angular rotation yet at all. I'll have to go back and handle that. The spawn box is okay. Oh, they're really spongy and jumpy. Really spongy and jumpy. Let me see if I can. I don't know. Last time I tried this, I was going wild. Can't give a follow. Well, just know the game itself is not day one for sure. The actual game is this is more like a side project of game one. Because I already have an existing physics engine I'm using, open source one from NVIDIA. But as a side project will occasional work and replacement. Occasional work and replacement. Yeah, keep off. But back to physics. Yeah, I don't do any kind of friction at all yet. So that's going to be interesting. That's going to be interesting. 5 is too much. Let's go back down to 3 because I just want to make sure rotation looks good. Oh, it doesn't look good. I think I know where that's coming from, though. I think I know. Looks like it's time to pay the piper a lot more than I thought, but first working rotation on colliding boxes. Is a good submission to keep track of. Hey, where's the line count? It just disappeared. Just disappeared. Oh, I guess I just don't need to reinstall it here, huh? Yeah. Yes, I do. Okay. Can do that. Cool. Just don't take 300 years like last time. Please. This is the C++ line counter I have for my own project. Boom, go. It's almost 8 hours. It's been way too fun, way too fun. And it's still a little extension, takes 300 years in 2026. Jesus Lord. Silver iteration. It kind of makes sense. I think the problem is I wasn't aware that Slivic and strain will affect both bodies. That's what I need to do. I wasn't aware of that. Hallelujah. Hallelujah. Oh, yeah. Zero before, it was pretty freaking annoying. Bro. Maybe I need to rebuild that. Maybe that package I'm building is just no bueno anymore. Kinda sucks. Wow. Wow. I did not like my extension. Interesting. Okay. Remove that. Hmm. Hmm. Oh, would it even be happy? I better close down. Better close down. Bro, why is it taking so long? Oh, fun. Play quick chess game. All this continues. Would you go there, buddy? I will take it. I will snake it. Do I want to? Yeah, let's do it. Let's do it. Curious if this is good or not. I imagine it's good. Eventually. Seems to be fine. Go here. Go there. Hmm. Maybe take and check. It'll be up a pawn. I'm tempted to play all this, but with that rook active still, kind of scared to do that. Kind of scared. No chance. He ain't got no chances, son. Okay. Okay. Bro. That extension is gone, so why is still complaining? Ugh. Well, that might be the end of that, unfortunately. Might have to repair Visual Studio, so I might as well call it almost 8 hours in this physical coding. Very sad. Very sad. Yeah. Repair. But meanwhile, hey, which folder is this? And why is this not latest build? Excuse me. I've been sitting in debugger for this long, for half an hour, man. I need to compile more often. Oh. Okay. Well, this is gonna take its sweet ass time, so GG's until tomorrow, when physics shall continue. Till then, a tiniest rate of all. On who? Sure. Sure.
Actually, cancel it. Cancel it.
Until tomorrow.